This is example 2 in lesson 5.4, and I'm going to jump to part B, but I most certainly can go back and make other videos if you need to see some. But this is where we're going to use the distributive property. So what we're going to need to do is use the methods we just talked about in example 1 to multiply that 2 root 2 by everything in the parentheses using the distributive property. So 2 root 2 times 4 root 3 would be 2 times 4, 8. Root 2 times root 3, root 6. 2 root 2 times 5 root 6 would be 2 times 5, 10. Root 2 times root 6, root 12. Root 12, we know, has a perfect square that divides evenly into the 12, and that is 4. So we'll break this down to the square root of 4 times the square root of 3 with our 10 out in front. Square root 4 is 2, so we have 10 times 2 root 3. And so what we have is 20 root 3 as our latter term. Our first term is 8 root 6, and so we're just going to take 8 root 6 minus 20 root 3. Since square root of 6 cannot be simplified any further, these are not like terms. It's kind of like we have an 8x minus a 20y. Those are very different, and therefore we're done. This is our final answer here in part B. So this is part D of example 2, and I wanted to do this one because it has cube roots rather than square roots. We're going to go about it in the very same fashion. We're going to distribute, and so we're going to get just a 5 out in front because there's a 1 in front of this one. So 1 times 5 is 5. And then cube root 2 times cube root 4 is cube root 8, which is a perfect cube. That becomes 5 times 2 because the cube root of 8 is 2. Now if I distribute the cube root 2 times the 3 cube root 16, I'll have 1 times 3 is 3. Cube root of 2 times cube root of 16 is cube root of 32. Now 32 is not a perfect cube, but it is evenly divisible by our smallest perfect cube of 8, because the next perfect cube is 3 cubed, which is 27, and 27 does not divide evenly into 32. So I'll break apart this cube root 32 into cube root 8 times cube root 4, because 8 times 4 is 32. Cube root 8 is 2, and we'll just have to leave that 4 underneath the other cube root. It is a perfect square, but it is not a perfect cube. Once again, these are not like terms because one has a cube root of 4 with it, the other does not, so we cannot simplify any further. This is our final answer.